Okay, so previously we looked at one type of interest. Okay, remember interest was when, say, you put money into a bank, the money grows. Or when you borrow money, you have to pay back some extra, not just what you borrowed. Okay, we looked at simple interest last time. That was where the money grows by the same amount each time. And this time we're looking at compound interest, which is pretty much the same thing, but rather than growing by the same amount each time, we're growing by the same percentage each time. Okay, it's going to change the calculations a fair bit. Okay, we'll take a $40,000 investment at a ridiculous interest rate of 10% per year, just because it's easy to work with this percentage, and we'll let it sit for 3 years and see what happens. So imagine this $40,000 block here. Okay, we'll cut it into pieces where each one is worth 10%. The idea is that every year the money should increase by 10%. So this green increase should be worth 10% of our initial $40,000, which is $4,000. Okay? Now everything we've done so far could well be simple interest, but here's a difference for compound. Because now we own this green $4,000, it's our money, right? So that means that this $4,000 can get sucked into the account so that now we have a total of $44,000, not just $40,000. So that means that the sort of value of our bank account will update, okay? So that means the following year, when we cut this guy into pieces, where each one is worth 10%, you'll notice that this 10% chunk is a little bit bigger than last time. Okay, so when we increase by 10%, this 10% piece is actually 10% of 44,000, which is now worth 4,400, or 4,400, not just 4,000 anymore. Then this 4,400 will get sucked into the grand total again, giving us our current amount now of 48,400. So now, we'll do this one more time for the third and final year. We cut this guy into pieces again, and this 10% chunk here is going to be even bigger than last time. And now when we increase by 10%, we find that a 10% piece is 10% of 48,400, which is now 4,840. Okay, and so by the end of the third year, we're now looking at a grand total of like 53,240 or something. Okay, alright, let's sort of recap how we got here. Okay, we'll bring back the starting amount as well as the amounts at the end of each year, each updated value. Okay, now notice we updated our amount 3 times. So we hit the 40,000 with 3 10% increases. And importantly, it was 1 for each year. Okay, and we didn't have to only update once every year. Like, computers are kind of faster than that these days, and we'll soon see an example where we don't. But because in this case, that's what we calculated, okay, what we would say is that this was compounded annually. Okay, so in this context, when we talk about how often interest is being compounded, just think of how often our money is being updated, okay, how often the money gets to grow. It's worth pointing out that if we look at the interest earned over the course of each of those years, then we find that the amount of interest we're earning increases. That's because as the money grows, that fixed percentage, the 10% thing, is going to be worth more each time as our bank account grows. Okay, that 10% doesn't stay the same, it grows with the value of our account. Okay, so compounding more frequently will always give us just a little bit more interest because it speeds up that snowballing process. Okay, one last thing before we move on. How would we get this final 53,240 in one step without drawing the picture like over and over again? Well, let's think again about what happened to the initial $40,000. We know it's going to grow by a percentage a bunch of times, so it's super important to be clear on what percentage it's growing by, as well as how many times the money gets to grow. Those two things will be really important to keep in mind. Now in this case, because it's compounding annually, we're thinking in years, so the percentage is just the given 10%. and the money gets to grow 3 times. But things will change if we're not compounding every year, which we'll look into in the next example. So how do we increase by 10% 3 times? We'd take this 40,000 here. To increase by 10% would be to multiply 1 copy of the original plus an additional 10%, which is the 0.1. Then to repeat a multiplication 3 times, well, repeated multiplication, we can use a power for that. So we use a power of 3. So that's how we can work out the final amount of a compound interest investment in one go. Think about what percentage you're growing by and how many times you get to grow. Okay, and then you can use an appropriate multiplication and repeat it by using a power. So how does the compounding period change this? Well, we'll use the same $40,000 investment, but we'll dial the interest rate down to 9% and make it compound monthly. So this means that the money will grow and update every month instead of every year. So let's see what this looks like. This will be a timeline counting the number of years. So our investment is lasting in total 3 years. But because things are happening every month, we should chop this timeline sort of further into months, so 12 for each year. First, let's think about the interest rate. It's 9%, but that's 9% for the entire year. So if we need to dial this back to every month, then we need to divide it by 12, which gives 0.75%, but really, the actual number, as usual, isn't as important as seeing where it came from, which was that 9% is the interest rate for the whole year. You divide it by 12 to get the interest rate for just a month. Okay, in the previous example, when we were compounding annually, each time the money increased, it would be growing over the entire year because we were compounding every year. But now we need to break this up into months, so actually the money gets to grow 12 times each year. And that's going to happen across all 3 years, which I'm sure you know is 36 months, but the significance here is that our money will get to grow 36 times over the course of this 3-year investment. Now, this gives us both of the crucial pieces of information we need to think about when doing compound interest, right? How many times the money gets to grow, which in our case is 36, and what percent the money grows by each time, which for us is 0.75%. So how much money will we have in the end? Well, it'll be the $40,000 we started with. And now we want to increase by the 0.75%, but again, because the important part wasn't so much the exact number as it was how we got there, which was the 9% annual interest rate split into 12 parts, so divided by 12, we might put that in instead. Okay, and we want to repeat this increase 36 times, once for each month, so we take a power of 36. And that gives us a final answer of 52,345.81, or something like that. Okay, a final example here, where we need to work backwards a bit. Now, of course, when we're starting to vary the problems, there's many different types of stories we could come up with. But hopefully this example will give you the approach for solving these types of questions. So we're told the initial and final values of an investment, as well as the duration and the fact that we're compounding biannually. That just means twice a year. Our main approach here is to try to translate the story into maths that you can work with. So the story is that $50,000 grew into $60,949.72, so let's try to write that out. We have 50,000. We want to increase it by some percentage that we don't know. That's the point of the question, to find this unknown interest rate. But the R we're trying to find is the annual interest rate, so for the whole year, which means that if our money is growing every half a year biannually, then we need to divide this R by 2. And how many times will the money get to grow? Well, again, because it's biannually, it's twice a year, so over 5 years, it should get to grow 10 times. That's just 5 times 2. And we're told the end result of all this is it becomes 60,949.72. Okay, so after sort of translating the story into maths, we just need to solve this equation to work out what r equals. So the r is buried inside that huge bracket thingy, but it's all being multiplied by 50,000. So why don't we start by killing the multiply by dividing through by 50,000. And now we want to kill this 10th power on the outside. The way to kill a power is by taking a root. And because it's a 10th power, we take the 10th root. Okay, now that whole right-hand side looks gross, but it can go into a calculator, and we pretty much get 1.02, right? Not exact, but super, super, super close. You can check. Okay, so if 1 plus r over 2 equals 1.02, then that means r over 2 by itself must just be the 0.02, just the decimal part. Okay, so now you can kill the divide by 2 by doing multiply through by 2, and so 0.02 times 2 is 0.04. And as always, it's polite to write interest rates as a percentage, so we get 4% from that. So that's how you work with different bits of information. Okay, you still piece the story together as much as you can, okay, and try to turn that story into some sort of maths where we can use algebra, solve equations to get what we want. Okay, that's all we have for you today. So thanks for watching. See you around.